Hey guys, I'm Holly. I'm here with Donatiska, and today we're going to talk about volcanoes. It's going to be explosive. So what we're going to do is talk about how we actually get volcanoes. There are so many different types, and one of the things that we need to start with is the fact that we had that Earth in layers, and the Earth's crust is what the actual volcanoes are formed from. And then the bottom layer up under that is the mantle. So a volcano is actually a vent or a fissure in the planet's crust through which lava, ash, rock, and gases erupt. It's also a mountain formed by the eruptive products that just kind of keep building. So we have lots of volcanoes on the Earth, a lot of them, but they occur when those plates actually separate or get the weak points so that the lava actually comes through. And then sometimes, especially under the water, under the ocean surface, the Earth's crust is already so thin that the lava just pushes its way through. There's just so much pressure. But what we're going to talk about today is two types of volcanoes that definitely occur when the plates have a little crack or a fissure in them, and all of that lava has to go somewhere. So like we talked about before, there's plates like jigsaw puzzles of the Earth's crust. There's continental plates and oceanic plates, and so or crust. And what actually happens is they're called tectonic plates, and there's about 7 large ones and 152 smaller pieces that make up this. Now, at the boundaries of the plates, where they move past or they push under or they move away from each other, the magma is lighter than the solid rock around it. So it's often able to force its way through the cracks. It can explode from the vent, or it can flow out just kind of like a coffee mug. Like if you spill the coffee, it just kind of oozes out. It doesn't always have to be super explosive. Magma that has erupted is called lava. And just to show you a little bit about, scientists often call this the ring of fire. And that's because this red line right here is where there are so many volcanoes. They literally call it the ring of fire. Kind of reminds me of Johnny Cash. But that's because that's where those tectonic plates meet other tectonic plates. And so that's where the volcanoes are going to form, because that's where the Earth's crust has a little crack in it. But it's really cool. So it's over here. It's kind of in between North America and South America, and then Asia and Australia on the coast right here. Really, really cool, this whole ring of fire. Now, there are volcanoes all over the world, but that is just one of the most concentrated places. So we are actually going to talk about 2 different types of volcanoes today. One is the one that most people kind of know. It's the most well-known, and it's the one that there are the most of in the world. It's called a cinder cone volcano. It's a symmetrical shaped cone that, and it actually can occur as a single volcano or secondary volcanoes known as parasitic cones on the sides of stratovolcanoes or shield volcanoes. Airborne fragments of lava called tephra are ejected from a single vent. And then the lava cools rapidly and falls as cinder that build up around the vent, the crater at the top. And so it's very explosive. It's not anything that just kind of oozes out or anything like that. So much pressure and so much heat, just can't take it anymore, and they explode. And when they do, they really explode, sending stuff all kind of in the air. There's ash and, like we said, cinders, which is actually airborne pieces of lava. But the other one that we actually have right here is a stratovolcano. It's also called a composite volcano, and the reason that it's called the composite volcano is because it has alternating layers of lava flow, ash, and block of unmelted stone. They're larger than the cinder cones, rising up to 8,000 feet. And they're conduit systems of vents leading from magma reservoir underneath the surface. They're very violent when they erupt because pressure builds up in the magma chamber as gases. And then when the magma reaches the conduits, the pressure releases and the gases explode. Kind of like when you shake up a can of soda and then you open it, you know it's going to go everywhere. It's just because that pressure has built up underneath there. So one of the examples is Mount St Helens, which is in Washington State. It's a stratovolcano. And on May 18th, 1980, it actually erupted. And approximately 230 square miles were completely obliterated. 57 people lost their lives. And then over the course of the day, winds blew 520 million tons of ash eastward across the United States and caused complete darkness in Spokane, Washington. Could you imagine it just being completely dark, and the only reason is because there was so much ash in the wind that it was completely blocking the light from the sun? It's really crazy. So they can really, really change our world. So we talked about geologists a little bit before, and this is definitely where geologists help protect us. They're learning more and more about how to predict what types of eruptions, when they're going to erupt, and then also with earthquakes. So just really, really cool. They've studied things that have happened to help kind of see what might happen in the future. So what we're going to do today is we are going to dissect this stratovolcano, or this compound volcano that we have, and we're going to talk about some of the parts of it. So right down here we have the mantle. This is actually the mantle, and then this is the reservoir, the magma reservoir, and then these are the actual rock layers of the Earth's crust. Now what happens is if two tectonic plates, they get a little crack in there, and there's less force to actually keep that pressure underneath the Earth's crust, that magma will actually make its way up through the vent. This is the vent, and then this is, like we said, a compound volcano, so you can actually see the layers of ash and the lava that flow down, and it just kind of keeps building up. It just keeps making itself taller and taller. So we are going to make our own volcano today. Super exciting. We are going to make this with good old baking soda and vinegar. But we're going to add a little bit of dish soap. So we've got our dish soap in here. And just for cool effects, we're going to make our lava. So we're going to put in some food coloring. Let's put some red and yellow to make orange. After you put those together, you're going to mix them together really well. Looking like magma already. Not near as hot though. And then what we're going to do is actually mix this together with our vinegar. I'm going to pour some vinegar into this to make it a little bit more easy to come out. And then we're going to put it in with the rest of our vinegar. So we're going to mix that together. Put a little bit more in there. We can always add more vinegar if we need to. So we've got our vinegar, our food coloring, and our dish liquid. And then we have our baking soda. So we're going to go ahead and pour the baking soda in there. And so, like we said before, when that volcano erupts, the lava is going to come out, but also one of the most dangerous parts of the volcano is not just the lava, but it's actually the gases and the ash that come out as well. That is what basically just blackened out the sun from Spokane. And that's actually what happened in Pompeii with Mount Vesuvius. It was not the lava, it was actually the ash and the gases. So what we're going to do is actually cause the chemical reaction between this is going to actually make carbon dioxide come out. Probably not going to be able to see a whole lot of it, but here we go. So it rises up the vent, and then it finally rolls down. So there's that lava, and you can see it'll actually make another layer onto our stratovolcano or our composite volcano. It's actually going to keep making layers as many times as it erupts. So guys, I hope you enjoyed our little science experiment today. And you can definitely have fun making one of these at home. I had fun making this one, but we will see y'all again later. Have a good day.